Now I am going to explain very important chapter, chapter 4. It is chemical bonding and molecular structure. In this video you will see the brief introduction to the chapter, what you have to study in the chapter. So first I am going to explain about the meaning of chemical bonding. So chemical bonding means the attractive forces. These are actually the forces of attraction, attractive forces between different atoms to form molecule or molecules. So this is the chemical bonding. So chemical bonding is nothing but the attractive forces which keeps the different atoms together. So you can see this is the one point, that attractive forces. So the forces they keep together. Now we will see why atoms combine to form molecules. Question is why? We will see the question, why atoms are combined. Why atoms are combined to form molecules? Actually, atoms are unstable. Atoms cannot remain as it is. So, by combining atoms, there is formation of molecules. So, when the molecules are formed, there is the stability. So, answer is very simple. Because molecules are formed by the participation of valence shell electrons, or simply valence electrons in the atoms. So the valence electrons or the outermost electrons. So the electrons which are present in outermost orbit of an atom, they only take part in the formation of chemical bond, no other at all. So keep in mind that only the valence electrons or electrons in the outermost orbit, they take part in the formation of chemical bond. Suppose we have hydrogen, simplest. So one H, and it will combine with other H atom. So these are the atoms. These are two atoms, and there is formation of H2. And what is this? This is the molecule. So by forming the molecule, the atoms they join together and the molecules becomes stable. So molecules are formed by electrons and so the atom. Or you can say molecules are stable than atoms. No, molecules can remain as it is, and all the atoms cannot remain as it is. So this is there about the point. Now coming to then the classification of chemical bonds. So chemical bonds are of the following types. First is ionic bond. Ionic bond, it is also called as electrovalent bond. Then second is covalent bond. Third is coordinate bond. There is the coordination between the different atoms. Coordinate bond. Fourth is metallic bond. metallic bond. Now, out of these three are the true bonds. First three are the true bonds. Means the molecules formed are by either ionic in different conditions, covalent or coordinate. So these are the three important true bonds. Now, fourth is metallic bond. Fifth is hydrogen bond. Hydrogen bond, you will see later on in this chapter. Then six is, something different types of bond. Van der Waals bond. So these are some important ones which you should know. Now we will see them in detail in some part. In this chapter there are some important points to understand, and the first is Lewis structure. Lewis structure, and this is the simplest way, or it is Kojel-Lewis approach. Kojel-Lewis approach. Now this Lewis structure, it is the representation means the drawing or pointing representation of the valence electron, or valence electrons means the electrons in the outermost orbit. Valence electrons present in an atom. It is understood. So this is a structure. It was proposed by two scientists. Proposed by Kojel and Lewis, the two scientists. But the important is the Lewis structure. And so how to draw the Lewis structure? Actually, we have this hydrogen 1 electron, so simply put here and just draw here a dot. This indicates the electron, that one electron is outermost orbit. Similarly, we have the chlorine. So for this, you should know the atomic number. Chlorine 17, 2, 8 and 7. So here we write down the symbol similar to written, and then 7 electrons has to be drawn. 7 electrons. How? 1, 2, 3, 4, 5, 6 and 7. So this is the point. Other way, we can have this also H plus, or we can have this cross. We do this to differentiate. If the number of electrons, number of atoms are more, then the electrons of different are distinguished by this. Similarly, it can be represented like this, it can be represented like this, so as to have the demarcation. Similarly, it can be represented just nothing there. The point is to distinguish the different electrons. So this is the Lewis symbol. So the arrangement, it can be in an atom, it can be in a molecule also. Like take the case of CO2, carbon dioxide. So CO2, carbon, it is like this. Here double bond. So this we can draw here, and we can draw here oxygen. So these are the bonded electrons, and here these are the electrons which are non-bonded electrons. So we will see later on. So we can have the representation. So this is the all about the Lewis structure. We can do in different cases as well. Like say one more example, this CH4. methane molecule. So methane molecule just here and here. Just I'm writing because I know the atomic configuration. I have learned or I remember the atomic number. So see carbon 6 configuration 2 4. So 4 electrons, 1 electron, 1 electron, 1 electron. This cross of carbon, of hydrogen, this one. Just nothing compulsory, children, nothing compulsory. Just to have the distinguishing. Similarly, here we can have like this: oxygen A 2 and 6, carbon just I have written. So similarly, the oxygen 6 electrons. See here 2 to 4, 5 and 6. But why I have differentiated? The reason is very simple. To indicate that the dotted electrons are taking part in chemical bonding, while these electrons, they are non-bonded. They are non-bonded means they do not have participated, but they don't have participated in chemical bonding. So this is there. So this is all about the Lewis symbol. See here. So this is all. Now next important point is octet rule. So octet means 8. So it is defined as the presence of 8 electrons in the outermost orbit of an atom in the molecule. So it is defined as the presence of 8 electrons. 8 electrons. Mind, 8 electrons in the outermost cell. Outermost cell or outermost orbit or outermost orbits. It is octet rule. But there are some exceptions also, which we'll see later on. So, actually, when the molecules are formed, during the formation of molecules, atoms, they take part, atoms are involved, and it is due to the, either the sharing of electrons or the transfer of electrons in different conditions. So, there's the completion of octet. So, what is so? It is because all the participating atoms in the molecule, participating atoms in the molecule have their octet complete. So their octet is complete, and so by completion of octet they become stable. So other point is by completion of octets, the molecules or molecule acquires stability. So this is the reason. All. But there is one point, that one exception, that hydrogen, hydrogen. When there is formation of H1 form H2. So here there is the one electron. So here there is no octet. And we say here duplet. So it is duplet. It is one exception. Hydrogen is one exception. It is called as duplet. So duplet is there in case of hydrogen. Now coming to exceptions, which are very important. Exceptions to octet rule. There are some exceptions. First is the electron deficient. Electron deficient species. Electron deficient species. Second is, electron rich species. Electron deficient and electron rich. So first I am going to explain electron deficient. So then indicates molecules having less than 8 electrons in their valence shell. So, when the number of electrons are not 8, they are less than 8. So, there are some examples like BF3, then there is BCl3, and there are many more. So, first I am going to explain about this one, BF3. So, boron, again children, atomic number, electronic configuration 2 and 3. Boron, here 3 electrons of boron, 1, 2 and 3, 1 fluorine. So fluorine, this second fluorine and this third fluorine. Now fluorine, atomic number 9, 2 and 7. So again, it is not compulsory to mark cross or plus, but just to distinguish we do like this. It is not necessary. But here I am marking here. Again, this fluorine, one electron is here, one electron is here. Now see, here there is the formation of bond, here the octet is complete. Here is also octet is complete. This count 1, 2, 3, 4, 5, 6, 7, 8. In this 1, 2, 3, 4, 5, 6, 7, 8. In this 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons are there, no other 3. But what about this? 2. Just now there is a mathematics concept, union and intersection. So 2 electrons and 2 electrons. So here we have. So this is electron deficient. Now coming to electron rich. So again same, molecules having more than 8 electrons in valence shell, more than 8 electrons. So it is SF6, PCl5, these are the some examples. SF6, PCl5. These are some examples. So see here, sulfur, atomic number 16, configuration 2, 8 and 6. Phosphorus, this 15, 2, 8 and 5. So we can draw again like this. Here phosphorus left with 5 electrons, 1 electron, 2 electron, 3 electron, 4 electron and 5 electron. Just at equal distances. Children, all the electrons are present at equal distances. So 1 chlorine again, see, I will write down the chlorine also, 17, 2, 8 and 7. So here put 1 chlorine, here put another chlorine, here put another chlorine, here another chlorine, here another chlorine. Again 1 electron has to be there, so here I will mark cross, here cross, here cross, here cross. And so here cross like this. Keep on counting. Just very simple. You can do it on your own very easily, provided you know the atomic number. Similarly, like this also, And the last one. Now see, octet is completed. Octet is completed here. Here also octet is completed. 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 But see here, the electrons 2, 4, 6, 8 and 10. So phosphorus here. Phosphorus 10 electrons. So this is the exception of octet rule.